Hi, this is Halal. In this video on Mathematical Economics series, we will discuss about solving linear equations with inverse. That is, if we are given a system of linear equations, we can solve those system of linear equations using matrix algebra, and here using the inverse, which we have already covered in the earlier video. Now we will also cover this inverse in this video also. Now if we are given a system of linear equations, let us say x plus y plus z is equal to 6. Similarly, 2y plus 5z is given is equal to -4, and 2x plus 5y minus z, let us say, is equal to 27. If we are given a system of linear equations, we can solve these equations using matrix algebra. Now first of all, we will transform these system of linear equations into the matrix form, that is converting these equations into matrix form like ax is equal to b. Here this a is the coefficient matrix, this x is the solution vector, and this b denotes the vector of constant terms, constant terms. Now we will convert these system of equations into matrix form. The first is the coefficient matrix. We take the coefficient of this x, y, and z in these, so this will be the coefficient matrix. Now the coefficient of x is here 1, coefficient of y is 1, and also z of 1. Here the coefficient of x is not involved, so the coefficient will be 0. The coefficient of y is 2. Similarly, here the coefficient of z is 5. Here the coefficient of x is 2. Here the coefficient of y is 5, and coefficient of z is -1. So this is our a. Now this is multiplied with x, that is the solution vector. Solution vectors are these x, y, and z. The variable vector, that is x, y, and z, which is equal to the b. Here b is the vector of constant terms, that is 6 minus 4 and 27. 6 minus 4 and 27. So we are here with two column vectors. Now we have to first of all see the inverse, that is we have to find inverse. Because we can solve a system of linear equations, the formula for solving the system of linear equations is given by let us use the another color here, that is x is equal to a inverse times b. So this is the formula for finding or solving the linear equations with inverse. So for that we have to find the inverse. So let this be our a. This is let a is equal to this column, this matrix 1, 1, and 1, 0, 2, 5, 2, 5, and -1. Now first of all we have to see whether it is a square matrix, because we can find inverse only for a square matrix. Here it is a square matrix because number of rows are equal to number of columns. This is 3 by 3 matrix. Similarly, we have to find the determinant also. For finding inverse, first we make sure that it is a square matrix. Second, the determinant should be greater than must not equal to 0. That is, the determinant of this matrix should not be equal to 0. So we have to find the determinant. So we will see the determinant here. He is, let us say a is equal to now 1, 1, and deleting the row and the column in which appears, and multiply this with the this determinant, that is 2, 5, 5 minus 1. Then this is plus, now this is minus. as we have seen in earlier videos. This is -1, and multiplying this with this 0, 2, 5, -1, that is mentally deleting the row and the column in which it appears and multiplying it with the remaining elements, that is 0, 2, 5, -1. Similarly, we have this +1. Now deleting the row and the column in which it appears and multiplying the remaining elements, that is this determinant 0, 2, 2, 5. Now solving this will give us, that is 2 into -1, that is -2. Similarly, -5 into 5, that is 25. Here we have plus -1, multiplying this 0 into -1, that is 0, and -2 5s are 10, plus 1. Now here this is 0 into 5 is 0, minus 0 minus 2 2s are 4. Now further solving this will give us, this will become -25, -2 is -27. Here -1 into -10 is +10, and here we have this -4. Now this is equal to -27 and -4 are -31, and +10, that is equal to -31 plus 10, -31 plus 10, that is equal to -21. Therefore our A is equal to -21. That is, here determinant is not equal to 0. Therefore inverse exists. Inverse exists. Now this was the first step. After that, we have to find the inverse. To find the inverse, we have to find the cofactor matrix. We have to form the cofactor matrix. That is cofactor matrix is given by, that is denoted by C. We will denote this by C. Now we have seen in earlier videos how to form the cofactor matrix. That is, we replace each element of the given matrix by its cofactors. That is, here it is 1. We mentally delete the row and the column in which it appears and form a cofactor matrix of remaining elements. So here is 2, 5, 5 minus 1. Here it is 2, 5, 5 minus 1. So this is the first element. Now the cofactor of second element will be deleting the row and the column in which the second element appears and taking the cofactor matrix of remaining elements. Here it is 0, 2, 5 minus 1. So I will write 0, 2, 5 minus 1. Similarly, this one, deleting row and the column, we are given 0, 2, 2, 5. Here it is 0, 2, 2, 5. Similarly, now we have to see this 0. We will delete the row and the column in which appears and form the cofactor matrix of remaining elements. The remaining elements will be 1, 5, 1 minus 1. That is 1, 5, 1 and minus 1. Similarly, here for this 2, we delete the row and the column in which this 2 appears and form the determinant. So we are given here then 1, 2, 1 minus 1. That is 1, 2, 1 minus 1. Similarly, for 5, delete the row and the column. This row and this column, we are 1, 2, 2, 5. 1, 2, 2, 5. So we are with these elements. Similarly, for 2, delete the row and the column, we get this very determinant. That is 1, 2, 1, 5. That is 1, 2, 1, 5. Similarly, here 5 appears here. Delete the row and the column. We are with 1, 0, 1, 5. That is 1, 0, 1, 5. Similarly, here minus 1, delete the row and the column. We are with 1, 0, 1, 2. That is 1, 0, 1, 2. So this is our cofactor matrix. Now further solving this. Now here the cofactor matrix have the proper signs. First is positive, second is negative, third is positive, fourth is negative, positive, negative, positive, and negative, and last one is positive here. So the sign changes alternatively from positive to negative. Now forming the cofactor matrix. That is, now this is 2 ones are -2, -2 minus 25, that is -27. Similarly here, this is 0 into -1 is 0. Now 0 minus 2 5s are 10, so this is -10, but here is also 1 minus in multiplication, so this will become +10. Similarly here, 0 5s are 0, minus 2 2s are 4, so we are 0 minus 4, that is -4. Similarly here it is 1 into -1, that is -1, and -5 into 1, that is 5, that is -1 minus 5 is -6, but here it is another minus, then this will become plus, so we are given here with 6. Similarly here 1 into 1 is -1, minus 2 ones are 2, that is -1 minus 2, that is -3. Here we are with 5 ones are 5, minus 2 twos are, here we are with 5 minus 2. Now let us, I have some concern here, what we will see whether it was the same determinant. Here we delete the row and the column in which appears, then we are with 1 2 1 5, so 1 2, here it is 1. Now this was a mistake. Now this is 1 into 5 is 5, minus 2 ones are 2, that is 5 minus 2 is 3, but here is here the sign is minus, so this will become -3. Similarly here this is 5 ones are 5, minus 2 ones are 2, that is 5 minus 2, that is equal to 3. Similarly 5 ones are 5, minus 1 zeros are 0, that is 5, but it is with this minus, that is -5. Similarly this is 2 ones are 2, minus 1 zeros are 0, so this is 2 minus 0 is 2. So this is our adjoint matrix. Now, or I will say this is C. Now we will take the transpose of C, that is interchanging the rows with column. If this is row, here we will make it column, that is -27, 10 and -4, -27, 10 and -4. Similarly 6 3 -3, this will become column 6 -3 and -3. Similarly 3 -5 and 2, that is 3 -5 and 2. Now as we know that inverse is given by this inverse, the formula for inverse is, the formula for finding the inverses, let us write this. A inverse is equal to 1 divided by the determinant and adjoint of A. Now this C dash transposing the adjoint matrix gives us the adjoint matrix. So this C dash is equal to, this is also our adjoint, because adjoint is equal to adjoint of A is equal to transpose of C, which is equal to here, that is -27, 10, -4, 6, -3 and -3, and 3, -5 and 2. So our adjoint is this matrix. Adjoint is the transpose of the cofactor matrix. Therefore inverse, A inverse is equal to, so I will write here Now A inverse is equal to 1 divided by the determinant which we have calculated here, that is 1 divided by minus 21 into this adjoint of A. This is our adjoint of A, that is this matrix, that is minus 27, 6, 3, 10, minus 3 and minus 5 and minus 4, minus 3 and 2. Now we are done with this inverse. Now the formula for finding the solutions of the given linear equations is that x is equal to A inverse times B. Now x is the column vector, that is the solution vector x, y and z. Now our A inverse is given, this is our A inverse, this whole part is our A inverse. So I will write this, that is 1 divided by minus 21, multiply this by minus 27, 6, 3, 10, minus 3 and minus 5 and minus 4, minus 3 and 2, and multiply this with this B, where B is the vector of constant terms, that is this 6, minus 4 and 27. So this is 6, minus 4 and 27. So here it is 1 divided by minus 21. Now multiplying these two matrices. Now we can multiply these two only when they satisfy the condition that the dimension of this here is the dimension of this matrix is 3 by 3. Here the dimension of this matrix is 3 by 1, 3 by 1. We have seen this in earlier videos. If these two numbers are equal, then we say these two matrices are conformable. So we can multiply them, and the remaining matrix, the resulting matrix will be of dimension 3 by 3 multiplied by 1. If these two numbers are not same, then we cannot multiply the two matrices. That is number of rows, that is number of elements in a row must be equal to the number of elements in the column. That is, here the number of elements are 1, 2, 3 in a row. Here the number of elements in second matrix are 1, 4 and 27, that is 1, 2 and 3. So here are 3 elements in column, here are 3 elements in row, so we can multiply these two. Now multiplying this minus 27 with this 6, that is minus 27 into 6 plus this 6 into 4, 6 into minus 4 plus 3 into 27, 3 into 27. Similarly, we are done this with row, so we will take another row. Then this is 10, 6, 10 into 6 plus this minus 3, minus 4, minus 3 and minus 4, and then minus 5 and 27, minus 5 and 27. Similarly, this minus 4 and 6, minus 4 and 6 plus minus 3 and minus 4, minus 3 and minus 4, and this 2 into 27 plus 2 into 27. So this is the resulting element matrix, that is the number of rows are 1, 2 and 3 and column is 1. Now doing the calculation here, that is 1 divided by minus 21. Now this is 6 7s are 42. Now 6 2s are 12, 13, 14, 15, 16, that is minus 162. Now 6 4s are 24, that is minus 24. Now 3 7s are 21. 21, 3 2s are 6, 7 8, this is 81. Similarly 10 6s are 60. Now minus 3 times minus 4 is plus 12. Now this 5 7s are 35, 5 2s are 10, 11 12 13, minus 135. Similarly 6 4s are minus 24 because of this minus. Now here this is minus 3 into minus 4, that is plus 12. Now 2 into 27, that is 54. Now further solving this. Now 162 and minus 162 and minus 24, this will become, that is 4 plus 2 is 6. Now 6 plus 2 is 8. Now this is 1 minus 1 86 plus 81. Now similarly here this is 60 plus 12, that is 72. 72 minus 135, that is 135. 72. Now 5 2 is 3. Now 13 minus 7, that is 6. So this will become minus, sorry, here it is minus 5 minus 2 is 3. So this will become minus 63 here. Now this is minus 63, minus 63. I hope the calculation gets right. Similarly here I have minus 24. Now 54 plus 12, that is 4 plus 2 is 6. 5 plus 1 is also 6. Now subtracting this by 24, that is 2. Now 6 minus 2 is 4. So I will get here, that is 42, and this is multiplied with this 1 divided by minus 21. Now further solving this will give us 1 divided by minus 21. Now adding these two, minus 186 plus 81, and that is 6 minus 1 is 5. Now 8 minus 8 is 0. Now this is here minus 1, that is minus 1 because of this minus, and here it is minus 63 and 42. Now dividing this by this 21 to form a single column vector, which is already a single column, but eliminating this, now we will divide these elements by this minus 21. So this will become minus 105 divided by 21. Similarly minus 63 divided by minus 21 and 42 divided by minus 21. So this will become, this minus minus will get cancelled. So here it is 21s are 20, 25s are, so it is here 5. Similarly 21s are 20, and 21 times 3, 21 into 3 is 63. So here it is 3. This minus and minus will get cancelled. 21 times 2 is 42. So this is 2. So we got 5, 3 and 2. That is x, y, z is equal to this. Implies x is equal to this 5, y is equal to this 3, and z is equal to 2. So this was the solution. So I will repeat here. We were given a system of linear equations, and we were supposed to solve them using the matrix algebra. First, if we are given a system of linear equations like this, we will transform these into matrix form. That is ax is equal to b, where a is the coefficient matrix, x is the solution vector, that is the variable vector, and b is the vector of constant terms. Here 6 minus 4, 27 is the constant term. So I have expressed this system of linear equations into this matrix form. Now for finding the solution, we use this formula, that is x is equal to a inverse times b. That is solution vector is equal to the inverse matrix times the vector of constant terms. So first we have to find the inverse. That is, for finding the inverse, the matrix should be a square matrix, which is here. This is a square matrix, and determinant should not be equal to 0. Here the determinant is minus 21, which we have calculated. So inverse exists. Now after making sure that the inverse exists, we can actually go for finding the inverse. Now if this is a matrix, ordinal matrix, we have to form a cofactor matrix. The cofactor matrix is formed by replacing every element in the ordinal matrix by its cofactors, and we have seen in earlier videos how to form the cofactor matrix, and in this video we have also elaborated this. Now this is the cofactor matrix. Now let us see, let us say this C is this cofactor matrix. Now transposing the cofactor matrix gives us the adjoint, that is C dash is equal to A dash G. A adjoint, that is ADJ, that is transposing a cofactor matrix gives adjoint, that is A, that gives us adjoint matrix. Here this was the cofactor matrix. We had transposed this matrix by replacing every column by row. If this was here row, we have made it here column. Similarly, this was row, this column, this row, and that column. Now then inverse is equal to 1 divided by the determinant multiplying by the adjoint matrix. Now that is equal to A inverse is equal to 1 divided by the determinant was minus 21 and multiplying this by the adjoint matrix. Now we are ready to find the solution, or to find the solution vector. This formula we use here, x is equal to A inverse times B, because we are done with this A inverse. We have found this. Now this A inverse, this x is the solution vector, so I have written here x, y, and z. Here x, y, and z. Here we have seen this is the solution vector, is equal to A inverse. A inverse is this this term multiplying with this matrices times B. B was the vector of constant terms. Now we have to multiply this. We have seen in earlier videos also how to multiply. Multiplication can be only done if the number of rows in the first column are equal to the number of elements in the row in first column is equal to number of elements in the column in second matrix. That is, here the number of elements in row are 1, 2, 3. Here also 1, 2, 3. That is, these two matrices are conformable. And we have also seen the formula for finding whether the two matrices are conformable or not. That is, we take the first matrix and see its dimension. The dimension of this matrix was 3 by 3. That is, the dimension was 3 by 3 of the first matrix. Here the second matrix has dimension 3 by 1. That means here the number of rows are 3 and column is 1. Here the number of rows are 3 and columns are 3. If the last number of first matrix dimension is equal to the first number of the second matrix dimension, that is this 3 into 3, and we write here 3 into 1. If these two numbers are equal, then we say these two matrices are conformable, and we can do the multiplication. Here these two numbers are equal, so we can actually multiply these two matrices, and the resulting matrix will be of dimension, here it is 1, so because 3 times 1, so the resulting matrix will be of dimension 3 by 1. That is, the resulting matrices will have 3 rows and 1 column, which we have seen here. The number of rows are 1, 2, and 3, and column is only 1. Now further solving this by this calculation, we got this minus 105 minus 63 and 42, and this is with this minus 1 divided by minus 21. So we have multiplied each element by this minus 21. So the resulting vector was this 5, 3, and minus 2. Here it is minus 2 because here it is minus 21. So it is to be remembered, this is here minus 2. So here will be also minus 2. Now the solution is, because this x is equal to 5, y is equal to 3 and z is equal to 2 here. These are the corresponding elements here also. This corresponds to this 5, this y corresponds to this 3 and this z corresponds to this 2. So the solution of this system of linear equations is x is equal to 5, y is equal to 3 and z is equal to -2. So this was all about solving linear equations with the inverse. I hope you enjoy the video. So for more videos on mathematical economics, please subscribe our YouTube channel Econ Maths. Also like, comment and share if you like this video. Thank you.